average.
Oh, yeah, that thing, yeah. It will take 40 minutes to get through that section. Crazy. There'll be yellow.
I'm fine with that so long as it's animated.
You're not going anywhere anyway, right? I think today you guys just think you should stay home and get home and rest.
Keep her away, can't be.
Can you put a refrigerator back a little bit better? It's not straight back, and this is too much gap here, I cannot put the rice in here. So put this one towards this way. There's a roller on the back. You can just keep going, I'll watch the water hose here, keep going. Just push back.
We have a conference at 11 a.m. It's stuck on something, you can't just push it back, you have to pull it out, find out what it's stuck on, and then push it back. I don't know what to deal with it right now. So what do you want me to use here?
Thank you for the cake.
No cooking rice today. We have leftover rice all over the place, all right?
Another day to finish that list.
Hmm?
Another day to finish that list.
This is all dry, it has to be cooked. So we're not going out today with all that traffic issue.
I'm not going anywhere, I need to stay home and get my business done. That's a question. Alright. Did you tell any friends at school about your birthday yesterday?
Yeah, they all said happy birthday.
Nice. Remember how you told them?
I don't know. They all found out somehow. I don't know exactly how.
Daddy did not. All find out?
Yeah.
That's why I asked about the time.
Yeah.
Asked you about the time.
Yeah.
How was the lemonade last night?
Great, delicious.
I didn't get a chance to even drink it. It's gone before I touch it.
It was more in the refrigerator here.
I thought it's all gone. Oh, it's all gone to butcher, right?
Put these refrigerators, put these avocados in the refrigerator. find a place where we're gonna eat stuff out of the refrigerator so you can do it. Put them in the bowl, put them in the thing, Hi, you made it, huh?
Yeah.
How was the traffic?
Not very good.
Yeah, it took me 40 minutes to get through there yesterday. That was crazy.
I don't know how to get this thing from stuff to the moon that. Oh. Okay, when you see the effort, it's
All starting to go down already?
Yeah. Number 1, the first one. Okay. Number 3, later. Don't do parts B and D because you haven't learned that either. Mrs. Redmond will teach you how to do B and D, and we'll go over it some other time. Hello.
Morning.
Oh, hi. Sorry, there's so much traffic on Berlin Canyon. It was
When did you leave
ridiculous.
that?
Huh?
9:30. You mean 8:30? We left. I think I left my house at 8:30. But I had to pick a Mac though.
Yeah, I do this.
Okay.
And
What are you guys doing?
huh?
What are you guys doing?
Right now in FRQ.
Alright.
I just like sat down. So
Yeah.
Oh really?
Just got there.
Just
Okay.
is race gonna be here?
No,
No, is he in Michigan right now?
I think so. Oh yeah.
Yeah, that's what I
He's posting
thought.
this story.
Yeah.
Did he?
Oh, yes, he did.
Michigan? Did he ever go to Michigan?
He's somewhere right now. I forgot. I don't know. He posted on a story something with his mom.
Okay.
Said he's hiking.
Okay.
Okay.
Cool. Here's the FRQ for y'all. I'll use race's paper then in that case. So look at it. Don't do parts B and D because you don't know that yet. Mrs. Redmond will teach it. And then sometime later, when she's taught it, we can go over it. It involves integration and net change theorem.
Mm-hmm.
B and C?
Do not do B and D.
B and B.
And
do-
I think I crossed out.
Yeah.
Oh no, you crossed out on his. You crossed out B and C.
Oh shoot, that's my bad. Do A and C.
A and
Cross out
C.
D. Cross C. Do A.
Just think about it.
Nice. I'm jumping down here. Use a calculator for this.
Okay.
Calculator required. Calculator required.
work together for this, or
Yeah.
what was the notation for
Vegetation.
Wait, which one are you talking about?
vector notation? Is there?
It's like how to write it.
Yeah.
Wasn't it like the R? Or was that the
I
R?
remember the R.
I know it's the spiky brackets.
Hmm.
And you did -3 t sine. Okay.
Mhm.
Yeah. Wait.
Well, define the acceleration of each component. You just take the derivative of each component.
Yeah.
Right.
And then I just plug in 4 or 2.
Okay. And then you would get.
So funny number. Yeah, just that way.
Yeah.
Oh,
So let me do that.
alright. That's what I got anyways.
Oh, wait. I remember what's it in.
What's the what did you put in front of the brackets on the answer? Is that a Y?
Where?
In front of the brackets, the
4.
oh. Okay. Okay.
Can you put back a small spoon, please, Jerry?
Is that around a spare calculator?
No. Advanced theory calculator.
I'll use my.
Is your phone?
I like that. Kind of small.
Did you get it? Did you get this for the second component?
Yeah.
Oh, just making sure. I just want to be sure. I put it right.
Do you find the the factor of the
What'd you say?
beyond the for part A?
Mm-hmm.
How do you find that? I don't know if I did that correct.
What did you get for the derivative?
Negative. Oh wait, no, not negative. 3. Oh no, negative 3 t sine t squared over 2.
Oh, I can turn the missing. Oh no, you're not missing anything. Never mind. It's a negative 3t sine t squared. But
Did I just calculate it wrong?
I think maybe you just put it in the calculator wrong. I got like a negative 11 something. That's what Matt got to.
Alright. Yeah, it's probably that. I think I know what it is.
I think so.
Okay, buddy.
Don't worry, I thought that was kinda cool.
Not mine.
What the fuck is that graph, bro?
Thank you for asking that. So
Cause I didn't get it. Cause it's 4 squared.
4 squared.
16.
4 squared. Oh wait, no, 4 squared is 16. Divided by 2 is 8. That should be great.
So I was fine with 8.
Negative 12. Yeah, that should be. That sounds great.
Oh.
Are you in? Are you in degrees or radians? That might be in.
Oh.
Yeah. Okay.
Nice.
Got it.
It's so awesome.
Is this the graph you have? Or no? Oh, what the heck? Oh wait, actually, what's your interval?
One's a different scale. Shoot, let me
Is it 0 to 4?
it's,
Or sorry, it should be 0 to 4.
oh, I didn't do the interval. How do you do that? I forget.
Window.
Oh, yeah, you just. Smart. Oh! Oh! Let me out. Okay, x max is 0. Okay, like this.
Okay.
Bro.
Wait, what did you put in for y?
I did this. Doing myself something.
No, I think I put in. Yes, I put my acceleration once. Never mind. Yeah, that's why. See, that would have been silly.
The absolute volume, velocity, speed.
Did you get 3 values for t?
Yeah,
Okay.
for part C?
Yeah.
Yeah, I got 2.22558, 2.832, and 3.6364.
Yeah, I got about that.
So,
Oh, but we're looking for
How did you?
first, so it's the first value. Okay.
yeah.
How did you do that? What did you?
For C.
Well, yeah. What was this whole equation or whatever system?
Okay, well this one, this should be.
Because I just don't know. So like business formula?
Yeah.
Yes, because look at this. So you got for your two values of the you got 0.443 sorry 0.433 and negative 11.87. So to find the actual speed of the particle, you have to. It's almost like a triangle because this is the horizontal component and this is the vertical component. So the line going between them is going to be the real like speed of the particle with both the horizontal and the vertical components.
We're
taken
using
into account.
acceleration though, too.
This is the accelerator. That's for A,
We're using the speed for.
Oh, and then you'll find.
and then you'll find the real acceleration is what I meant. For C, you have to do the same thing. You have to. This is the speed of the particle because if this is the horizontal component and this is the vertical component, the real speed of the particle is going to be the line between them.
Yeah.
Right. You get what I mean?
I'm just.
You remember
just
how
why-
in physics we were doing, you'd have to find the horizontal and the vertical
Yeah.
speed.
But why would it be horizontal and vertical acceleration?
We're not looking at the acceleration then.
For C, we're not looking at the acceleration.
Did you?
This is the speed,
Oh, you're using the first one. Okay.
the ones I give you, because that's the first.
Oh, okay.
Yeah.
I thought we were using the one from the
No, no, no.
Perfect. Perfect.
I started doing that, but that was because I just wasn't paying attention. So
I feel like I might have the answers a little bit more.
This is really engaging my brain to think critically. I like this exercise.
Okay.
So did you get a graph like this? Oh my gosh, I'm amazing.
Yours is just not correct anyways, because you kind of need it to hit 0. Wait,
Well, it needs to hit 3.5 because it's asking when is it.
oh, you're doing that. I'd subtract 3.5 and just find the 0. That's easier.
Oh,
Just put, yeah. So maybe yours is right, actually.
it probably. Well, let me like this. Maybe.
What's your window?
0, 4.
What's your y component, actually? Like the scale of y here on the window.
Oh, it's like -20 to 20. Let me just.
Here, go -10 to 10 real quick.
Well, let me just calculate the intersection.
That's true. Okay, hold on, your x's. Your first x's.
Give me those.
Yes.
Okay. I did it right, I guess. I think my window's big. That's why it looks weird.
It's a little freaky.
Okay.
Yeah, my y is half yours.
Yeah.
So I should.
Oh, so that's plus you take the other.
If I even said let me just see what it looks like definitely actually.
And then are we doing 3 or are we just doing 1?
Just one.
Just 1 right now, okay.
20 it still does not look like yours at all.
We don't know 3.
Is it still okay? I don't know.
But I have no idea. But you got the same answer though. This is the first time they intersected.
Yeah. Hold on.
Did you have the square root?
I did.
You did.
And then subtracted the square.
Oh, this. Wait, does this need to be squared?
If you get rid of the square root. So it doesn't need to.
No.
Unless you.
Oh yeah, right, because I put that anywhere. I don't know. Forget this. I forgot the same answer.
How many answers did you guys get?
For number 3, B, C,
Yeah.
3.
Okay, well.
You get 3 intersections on that interval, but it asks what time does the speed of the particle first reach 3.5?
Well, you still have the same points, so I have no idea. Yours just has.
So I put one answer because it asks for the first time it reaches 3.5. But you should get 3 intersections on it. Okay.
It looks like yours
Okay,
is-
what would you get for the first?
For the first one, I got like 2.225.
So,
Okay.
We're excited. Nice. Cool.
Yeah, I wish we could use Desmos on the AP test. I would like it a 5 for sure. I love Desmos.
How do you like Desmos more than a TI-84?
Desmos is easy.
Because Desmos is goated. I love it.
I like the TI-84 for like basic equations, but then Desmos is better for graphing, 100%.
I think it's just because I can type it a lot quicker, just like when I'm on my computer. When I'm-
Yeah, I guess you can type it a lot.
if I check when I'm checking things on like homework.
Bro, look at all these buttons though, man.
It's so
Desmos can't
cool.
do that. Desmos can't make lists and then actually they can do histograms and stuff like that. I don't understand that.
Okay, I should probably just forgot on effort to become used to write things out.
Yeah.
Well, I did not.
Then I'm gonna be happy.
So let me actually
Oh yeah.
write
I
this
don't like
in
that.
a better
I
manner.
don't like that part.
What'd you get for your first answer?
I got like a 11.8801. Or is that?
I got 0.4230, negative 11. Wait,
Horizontal component, vertical component.
did you get negative 11 or positive 11?
Negative one.
Okay.
For the speed of the
Yeah.
particle? Oh, okay.
Acceleration vector.
Mhm.
You only use absolute values when you're talking about acceleration and speed. Or not, sorry. Acceleration and magnitude. So like, you know how on the FRQ it says at what time does the speed first reach d.5? That means you want absolute values. Which
Okay.
is the same thing as magnitude, which is right with the absolute values there. And I use
Oh.
Pythagorean theorem. For the first one, it says find the acceleration vector. Nothing about that says absolute values.
Oh, okay, so for the acceleration vector, I did the, when I was saying my answer, I did like the triangle, like what you did for the velocity one. Like I did like the distance formula to find out the,
Well, then that's just the acceleration pretty much.
that would just be the acceleration.
Yeah.
Okay, so when it asks for the acceleration vector, it just wants to give the components.
And
Okay, never mind. I got negative 11 for my vertical component, so I think I got those ones right.
cool.
Alright.
For C, right?
Yeah.
For C,
It would just be. Well, how would you write that out? Because I know T equals like 2.225 around there, but
Yeah.
you say. Oh, because that's speed, so the absolute value of velocity.
I forgot I have to justify.
What's that?
Can you see very well? Or do you need like glasses?
Yeah. Dude, it's so funny. I need to get an eyelash repair kit. Mine just like the lens just popped out. It's in its case and everything. It just does that. And the screw's missing again.
what?
Oh, you're rewriting it all?
So it'd just be since 2.25 is less than all that. Speed first reaches.
We get 45 minutes to do this. Hi.
This is what the scoring guidelines say, and just so you know, just to prep, you know how like when you are allowed to use a calculator, they ask you to do more stuff because you have a tool in your hand, which means that you don't have to show as much of your work, right? And I think that's something that people normally trip up on when they're doing something like this because they end up spending more time than necessary to show their work. So just to show you that, that's literally all you have to do for part A.
Okay.
This ends.
Just write
Oh.
the thing.
Wow.
Just write the thing.
Mm-hmm.
Use your dy dx function on your thing and get that. And then that's all you have to do.
Oh, wow.
See that?
So you could just
Just write absolute value equals square root, plug in, find 3.5, use your calculator, it's 2.225. Like I wrote too much. Actually, I ended up writing too much. I didn't need to write any of this, but that was wrong in the first place. And I didn't need to write any of this. It didn't say like it. You don't even need to show that the first function, that first one is 2.226 and not 2.832. All you do is use your calculator, and then you get 2.2.
So you don't have to justify that it first reaches there.
No.
Just the value. Okay.
It doesn't even see it. It doesn't ask you to justify on this. that's just common with calculator ones, which is something that I need a bit of help on myself because I end up writing quite a bit.
Mm-hmm.
An equation and expression for speed. That would just be the first statement there, right? Where speed equals. Okay.
And you can use this notation, by the way, a of 4 for part A. A of 4 equals the vector horizontal component being second derivative of x at 4 and second derivative of y at 4.
Mm-hmm.
I ended up writing too much as well. I wrote acceleration vector at t equals 4.
Mm-hmm.
But that takes too much time to write, but instead you could just write a of 4.
Yeah.
So that sort of thing.
Smart.
Does anyone have any questions?
Nope.
Yeah. Okay. You want to move on to series?
Yeah.
Yeah, sure.
You know, the funny thing is, while I was looking at sequences FRQs earlier today, because I was trying to find something for sequences that we can do in FRQ,
Mm-hmm.
found nothing. Because all the FRQs that I see ask about a Taylor polynomial or a power series,
Yeah.
or a Taylor series, or a Maclaurin series, and we don't get to any of that until 11.8.
Mm-hmm.
But that's, it trips me up so much, man. Like, I'm sorry, I won't be able to teach that very well.
That's okay.
Because I'm very confused by it myself. So 11,
So.
the cool thing is that 11.3 through 6 is all very rudimentary and like
Mm-hmm.
the same thing over and over. It's just techniques, which I'm pretty good at. That's nice. Okay, 11.2. You remember what I said last Tuesday? What a series is? I didn't give you the formal definition, but what is it when you, like, if a series is something, then what's a series? If the sequence is this, then what's a series?
I do not remember.
I forgot.
We read it, right? Was that at the end of everything?
Yes. I don't think I asked you to write it down. I was just saying that.
Yeah, no, you said it.
I
Whoa.
just said it.
Yeah.
Well, basically, there's a keyword that it's gonna ask you to know, which is sum. As in, if a series is something like 2, 3, 4, 5, 6, and those are the terms. First term is 2, second term is 3, third term is 4, fourth term is 5. Then a series is 2, 2 plus 3, 2 plus 3 plus 4, 2 plus 3 plus 4 plus 5. So that the first term is 2, the second term is 5, third term is 9, fourth term is so on and so forth.
Mm-hmm.
Right, that's a series.
Oh, did we do that?
Right now.
Is that the sigma notation?
Yes, yes.
Oh, I like that.
You like that?
Mm-hmm.
Great, you'll have so much fun. Alright,
I think I did that.
okay. Now, the notation is going to trip you up a little bit at first, but yeah, that sucks, man. This book doesn't give formal definitions. I don't think there is. But it says, quote, in general, if we try to add the terms of an infinite sequence, A of n, we get an expression of the form a1 plus a2 plus a3 plus a4 plus a5 plus dot 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 plus a of n plus dot dot dot, which is called an infinite series, or just a series, because we only deal in infinite stuff in calculus most of the time. Here. There it is. Write that down. Stand up. Nice. You know, yesterday was my birthday.
It was your birthday?
Yeah, it was
What?
my birthday. birthday.
Whoa.
Happy late birthday, bro.
I know. Are you 17?
I'm 17.
Nice.
Dude.
I'm
welcome to-
officially one of you guys. Most of you.
But so, yeah, because you're actually me and him are 18. You're 17.
This guy.
That's true.
I'm officially one of your people.
We got 217.
I'm 17. That's very cool. Very cool. I like it. I like it. It's
Mace is still 17 too.
Yeah. Can't believe it.
Reese doesn't feel 17. I feel like he's like I would have guessed he's 18 unless I knew he was 17.
Feels like a college senior.
He's mature. He's
just
mature for his age.
You skipped a couple years.
Yeah, he's mature.
I love race.
Me too.
Great man.
Okay, so I'll write this. What's the series, guys?
A sum of. Wait, would it just be the sum of a sequence basically?
Yes.
Yeah.
Very. It's explained very badly.
Tell me what it's written down there.
Oh! Okay.
Oh!
A sum of infinitely many terms. Or, yeah, something like that. So adding the terms of an infinite sequence, which would be infinite series.
What was that?
Adding the terms of an infinite sequence, bracket a_n, close bracket, yeah, n equals 1 to infinity, we get an expression, yeah, a sub 1 plus a sub 2, a sub 3, which is an infinite series.
Not necessarily one. Not necessarily one.
Doesn't have to be.
Yeah, you'll see that a lot. Basically, like I'm gonna repeat this so many times throughout this course because this doesn't have to necessarily be one. I've never seen it be negative. It can be anything from 0 and onward. But for whatever reason, the book always writes it as one. Don't take it unless it says that. Now, if you focus on just the base of this, the series is a sum. That means, actually, let me write the notation first. Not necessarily. That's.
It's the sigma.
Yeah, it's a sigma.
Evan,
What?
do you do something like that?
I know comments on Sigma.
Or you tell me misrepresented something.
I remember it.
Bros, Miss Redmond said, what'd she say? She said,
She was like, does anyone, I don't know, she was like, does anyone know about Sigma notation? And then, I don't know, have you ever heard someone be described as Sigma? You remember that?
Yeah.
Yeah, I was like, I think I know a lot about Sigma, that's what I said. And she was like, oh really? I was like, yeah. Thank God she didn't ask me anything about it because I had no idea what Sigma was.
Nice.
I love it so much. Everyone in the class is just looking at you.
Very few laughed.
Nice.
I thought it was funny.
I thought it was funny too.
I got a joke. Very few would.
Anyway.
Alright. Now, one difference that I think might trip you up on what exactly is a series is how it's expressed. Let me expand this. So, does everyone understand this?
Mm-hmm.
It's the sum of the sequence A of n from n equals 1 to infinity. Yeah. Now, you would write that. If you wanted to expand it, you would write a of 1 plus a of 2 plus a of 3 plus a of 4 da 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 plus a of n plus da da da. Now, do you remember the difference between convergence and divergence?
Yeah.
Yeah.
Yes.
Convergence is when it's equal to infinity, or does not exist, or oscillates. Sorry, that's
Yeah.
divergence. And convergence is it equals a finite number.
Mm-hmm.
Same thing goes for series, right? If all of these approach, like if this is 1 plus 2 plus 3 plus 4 plus 17, or I don't know, plus something, you just keep doing plus, 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 and the numbers keep on getting bigger, your sum is gonna be infinity,
Mm.
right? But you can't actually have a sum of infinity. Nothing can ever equal infinity, unless it's a limit, right? But we don't have the notation limit here, so you can't say it's equal to infinity, but it approaches infinity, which means it's divergent, right? Do you think it's possible to have a series that's convergent?
Yes.
Yeah.
Because the sequence, well, I'm just imagining like a sequence where it adds like continually, like it increases very slightly, but what do you call it? Like each kind of, what would you, like each term would increase, oh, it would kind of decrease, I don't know. Like I can imagine like the first term would be like 3.01, next term would be like 3.001 or something like that. I don't know.
If
You
you
made
have
that
a
somewhere.
sequence where like the terms alternate between positive and negative, would that make it convergent? Like
Sometimes.
sometimes.
That's the alternating series you just mentioned.
Okay.
Yeah, that's in 11.5, which is personally my favorite series because it's really easy to deal with. And then it's critical thinking by Matthew's part, which is always awesome. But have you guys, Matthew, both of you are on the right track. We're not going to get into alternating series until 11.5 in like 2 weeks. But for now, yes, if you have these series and they eventually get lower and lower and lower, so this is 4, this is 2, this is 1, this is 1/2, this is like 1/4, 1/8, 1/16, this is like 1 something, right? You just keep going, Eventually the sum's gonna get smaller and smaller, right? The sum of a and 1, like the sum of 4 and 2 is greater than the sum of 4, 2, and 1. Wait, sorry, is less than 4, 2, and 1, is less than this, is less than this. But when you get over here, you're gonna be adding like 0.0000012, right? And eventually it's gonna converge. Like, have you guys heard the story of the tired, what was it called? The tired bartender or something like that?
No.
Okay, so basically it's this joke where a guy walks into a bar and says, I'll have 1 pint of wine, or no, I don't know, like 1 pint of liquor. So the guy gives him 1 pint of liquor, right?
Yeah.
And then the next guy walks in after him and says, I'll have 1/2 a pint of liquor. So the bartender gives 1/2 a pint of liquor. The next guy walks in and says, I'll have 1/4 a pint of liquor. So the guy gives 1/4 of a pint of liquor. And the next guy walks in after him and he says, I'll have 1/8 of a pint of liquor. At this point, the bartender realizes that all of these customers are members of the same party. So the bartender gets real tired with all of these jokes and just goes to the guy who asked for 1/8 of a liquor, 1/8 of a pint, and he gives him 1/4 of a pint and says, "No, you're serious," and he walks away. He's tired and he doesn't want to deal with an infinite line of customers from that party.
Mm-hmm.
You get what I'm saying?
Yeah. Mm-hmm.
If you gave the guy 1/4 of a pint of liquor and he asked for 1/8, how much does he have left over?
Enough for everyone else.
He has 1/8 left over, and he can give 1/16 of that eighth to the guy. He can give 1/2 of the eighth to the guy after him, half of that to the guy after him, 1/2 of that to the guy after him. Keep going, right? So what do you think is the total amount of liquor that party asked for? first guy asked for 4, or sorry, first guy asked for 1, second guy asked for 1/2, third guy asked for 1/4, and they just kept him going. What's the total amount of liquor that the party ordered?
2.
Okay. 2.
Mm-hmm.
That's convergence. If you can get me an actual physical finite number, then that means that the series is convergent. That's cool. I remember that joke I got like a year ago or something like that. Something about this. It still works for series, so that's nice. Here is, hopefully did they give, yes, they give a definition of convergence. Nice. Okay, write the definition down. Given a series of a of n from n equals 1 to infinity, and then if you want, you can write after that equals a of 1 plus a of 2 plus a of 3 plus dot 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 dot. If you want, you don't have to. Let S of n, so you remember how you said a of n? And you wrote a subscript n, where the n is a subscript. Here, write S of n, where n is a subscript and you write S regular, and then I'll explain after what S is. Let S of n denote its nth partial sum. Partial sum. So that S of n equals, keep writing, the sum of a of I, and I'll explain after why I'm using I here instead of the regular I, and a of I from I equals 1 to n. And it's not infinity this time. And if you want, you can also write equals a of 1 plus a of 2 plus a of 3 plus dot 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 plus a of n. But this time you don't keep writing plus dot dot dot, you stop at a of n. And I'll explain why after. Yeah. If the sequence S of n brackets, right, is convergent and the limit as n approaches infinity of S of n equals S exists as a real number, then the series, the sum of a of n is called convergent. And we write
A of I,
a of n, then the series a of n is called convergent. And we write a of 1 plus a of 2 plus a of 3 plus a of 4 plus a of 5 dot dot dot. Whenever you want to stop, you can stop and just summarize it with dot dot dot. Plus a of n plus dot dot dot. I wish there was a way I could screen print it. Equals S. So after you wrote the a of n plus a of n plus dot dot dot, right, equals S. You got that? Or simplify it, you can write the sum of a of n from n equals 1 to infinity equals S. The number S is called the sum of the series. If the sequence S of n brackets is divergent, then the series is called divergent.
So this is like when you said in the bartender joke, where so S would that be 2?
Yes,
Okay.
this is 2 in that case. Okay. I skipped ahead a little bit and I omitted what the partial sum is, so I'll explain that now. Basically, like, what if you had a sum that didn't go to infinity? Like, what if you went to a number? That's what we just said there, right?
The partial sum?
Yes, a partial sum. What do you think that would look like? Like if the sum is a of 1 plus a of 2 plus a of 3 plus all the way to a of n, and that's the sum, if that's the series. And what's the partial series? Where you don't go to infinity.
We would just end at A of n.
You wouldn't write this, is what I'm saying. Just stop right there. At whatever a of n is. So you write this. And you stop at n. Now unfortunately I can't have double meaning by writing n here and n here, because then you're saying the same thing. So we have to make a new variable. You remember what the variable was?
I.
I, yes. Like that. And we call this the partial sum as of n. Writing sum here because you should always keep it clear in your mind that this number and that number equal a number and not a series, because a series isn't an actual number, it's this thing. If you took away the pluses, you would get a of 1, a of 2, a of 3, a of 4, a of . That's the series, is the individual numbers. The sum is when you add them. So you want to keep clear conceptually that this number equals the sum of the series and not the actual series. Okay, they're kind of particular on that. It's the sum of the series. The same thing goes here, the nth partial sum. Not the nth partial series, because that's not a thing, that doesn't exist. This is the nth partial sum.
Wait, so is a series is a sum of terms?
A series is no. A series is an expression. That's what I think, but that's what they have here. Let me see. Unfortunately, book doesn't give right answers. Definitive answer. Okay, so it is the sum.
It's not in terms of a sequence.
Yeah,
So that would be the main difference.
yeah.
Okay.
But just when you're writing out actual numbers, you should always say, make a habit of saying, these numbers, this number,
Mhm.
singular, no plural, this number is the sum of the series.
Yeah.
So what would this look like? Because you noticed in the definition at one point that I said the sequence S of n, right? Where if I put it into a different context and I would say the sequence S of n. What would this look like if you had to write it out?
S plus S sub 1 plus S sub 2 S sub 3.
Yeah. Yeah. Sure.
Well, no, not plus, so just maybe, yeah.
Because now I'm back to sequences, right?
Mm-hmm. Yeah.
I said the sequence. But if I didn't, just for funsies, like I'm talking about concept here. If I didn't want to write S, what would I write? If I wanted to put the sequence in terms of A, what would I write?
Would you just do A1, A2,
You had to write for one with the first one. This is what the first term would be. What's the next term? If say the second partial sum, if like here, if I said that this was the second, sorry, if this was the second partial sum, then this would all look like, no, this would go here. Like that. This is what the second partial sum would look like.
Oh.
Okay.
So the second term would be A sub 1 plus A sub 2? Okay.
Plus 2. What's the third partial sum?
A of 1 plus A of 2 plus A of 3.
Exactly. Keep going. Right. This is what I mean when I say that this series is cumulative
Mm-hmm.
or is the sum. So it's kind of like, but I don't think of it like that. Yeah. So I'll give you an example. I'm kind of jumping all over the place. Sorry about that. But if I'm giving an example, say A of n equals I'll say 1 over 2. Yeah. Say that.
Mm-hmm.
If this is the sequence, then
first term would be 1/2.
Mhm.
Then it'd be 1/2 plus 1/4.
Is this what you're saying? Wait,
Yeah, 1/2 with the for the first term, right? Or
Yes.
is it?
is that right? Is that what you're saying?
Oh, I was saying first term would be 1/2, and then and it would be like comma 1/2 plus 1/4, comma 1/2 plus 1/4 plus 1/6.
Yeah.
Is it the sequence, right?
Yeah. I didn't write the bracket stuff.
Oh.
For brackets. I'm not talking about brackets, I'm just talking about the actual sum, the partial sum.
Okay.
In which case this is correct.
Oh, okay.
Yeah. But you're on the right track there. If I wanted to write the actual terms in the sequence, what would I write?
1/2, comma 1/2 plus 1/4, comma 1/2 plus 1/4 plus 1/6.
Yeah. But I don't think College Board would want you to do this. I think College Board would want you to combine the terms. So what would the second term be? Not in terms of a sum of two terms, but in just terms of the actual genuine number.
2/4.
And then?
Oops.
I'm doing it. My head.
3/4 plus 1/6.
22 or 24? 11
You
or
can
12?
simplify, yeah. 11/12.
11/12. Yeah. You wanna solve for the fourth term or say that's too much brain?
180. Yeah, we're good. I'm good at that.
I'm good too.
And it's the term though.
So that's it.
No, I'm not doing it.
Oh, okay.
I was writing it down.
So if I wanted to say, and let's go back to the bartender problem, what would A of N look like for the bartender problem? Remember the first customer ordered 1 pint. Next guy ordered 1 pint. And so on and so forth.
Just throw it aside 1/4.
Where we're at? Wait, what was the third one?
Third one was,
4th, right?
yeah, it was 1/4.
Okay.
So what's A of N?
Would it be 1/2 to the power of n minus 1?
Like that?
Oh, but then minus 1 on the end. Yeah.
Like that?
No. What you had? Sorry.
Like that?
Oh, yeah.
Yeah.
Smart.
So what's the
1 plus 1/2 plus 1/4 plus 1/8.
Mhm. How would you write that in some sigma notation?
Sorry.
Can't just see that. Would it be like sigma? The top would be n. Top is n. The bottom is I equals 1. And then and then a of I for the okay.
We could do better than that. We already know what A is.
Okay. Would it be like? Oh, would it just be what you have for a of n, but instead of n, it's I. Right. Okay.
So what would you say?
Maybe 1 over 2 to the I minus 1.
That's good. That's a partial sum. And then a regular series, or sorry, a regular sum of a series is if this was infinity, this kept going past n, and this was infinity, this was n, and this was n.
Yeah.
Okay. Okay.
So we've got partial sum down, infinite series.
Okay. Now, I need to show you a specific types of series. Now, we gotta get into, there's some special types of series. Special series that have special properties. So one of them is called the geometric series. Alright. And it's where every term is equal to the term, like prefacing it, the term preceding it, that's the word. Every term is equal to the term preceding it times some constant r. So it looks like this. Sorry, well, no. Be careful there. And then A of n would be, would be that. But what A of n would really be is, or should I write this? Times r. And you would have to specify A of 1. So you would make it a constant. So this actually fits perfectly into the bartender problem I gave earlier. What's A of 1?
A1's 1.
The very first pint that the very first guy ordered. And then what's A of n? Or sorry, what's R?
1/2.
1/2. Each subsequent guy orders 1/2 of what the guy preceding him ordered, right? Now, if you want me to show you the proof, I can, but that would kind of be redundant. But a prettier way to write this is actually A of n equals A times R to the n minus 1. This is what the book gives. This thing. This is called the geometric series. Now the cool thing that you can do with this series is that you can know the sum of the series, all as long as you know A and R. Do you remember what the original sum was for the bartender problem?
2.
2. Yeah. Here, you would write, if you wanted to solve for this, in any case where this is a geometric series, and A of n is A r to the n minus 1, the sum of the series is actually A over 1 minus r. Fact. Now there's a reason why a lot of this type of stuff, like that, where you get an expression and you solve it and you have A of r, or P or Q or any sort of thing that we're going to see in the next couple of weeks, is that it can get you the sum of the series, which is pretty big because just as like brainstorming, I don't know, like someone give me a series, any random series.
Wait, so series is a sum, right? Or yeah, so just like
Sum of the sequence.
1 plus 2 plus 4 is 8. Am I right? I don't know if I did that.
How about, okay, sigma,
You don't ever say sigma for this.
okay,
You
so
say
the
sum.
sum of
You know what, just for funsies, just because you said it, I'll say sigma.
yeah.
Okay, what was it?
Sum, obviously, going to infinity n equals 1, because that's like, that's what a series is.
Well, not necessarily 1.
Right, okay.
0.
And then we'll do 2 times n. Is that good enough? Or is that?
Yeah, that's alright.
That's fine, okay.
Yeah, that's alright. Okay, what's the sum of the series? What is it?
2. Wait, what would the
Like if I had to write, if I had to say a definite number here, what would go right there?
Well, I don't think that one would converge. That one would diverge, right?
Yeah.
'Cause it goes to infinity. Yeah.
Yeah.
So the sum, would you say it's infinity, or would you like say it's divergent?
I've never seen it written as infinity. It's a good question. Yeah, I've never seen it written as infinity. So I don't think you can do that. I think you would say, the only thing you can say here is divergent. Now someone give me another sum that you think is convergent, and then we can solve for it after.
I would sum, like, from n equals 1 to infinity of, let's see. I'm gonna ponder on this one for a second.
Something you think is convergent.
2 to the power of 1 over n.
2 to the 1 over n. That's a good one. Alright, find me the sum. Literally, get me a number. See if you can do it.
I was getting a call. Can I like go?
Yeah, go for it.
Awesome.
get me a number, get some kind of number that I can put here. See if you can do it. Just think and see if you can find the actual sum.
Let me see.
No,
I kind of agree with 3 right now. I think maybe, yeah.
Let me ponder for a minute.
Because if so, as n gets really big, the power is going to be like basically 0.
So it's
It's basically 0. Then that's like 2 to the 0 is 1.
yeah. So it's then it wouldn't be 3 though.
But then it wouldn't be 3.
Because the first one is 2,
Uh huh.
and then it's plus like a little less than 2, so it's all the way down to 1.
Hmm. Okay. So would it be? Hmm.
I'm asking them to find what that sum equals.
So.
I think you got it on the right track first off. You already know
Yeah.
that all the terms in the sequence
Uh-huh.
2 to the 1 over n are somewhere on the interval 1 to 2.
Right.
Right? They're
Mhm.
somewhere there. Which means that the final sum is going to be something that adds only terms from 2 to 1.
So I think it has to be more than 3 then, right? Because if it's, well, more than, it's adding things on the interval 2 to 1. The second term would be 2 to the 1/2 power, and that's like, what 2 to 1/2 power? Oh, to the square root of 2, square root of 2.
But it's an infinite amount of numbers between 2 and 1. So would it also just be divergent?
Yes.
Okay.
Okay.
Wait, infinite number. Wait, say that again?
Because it's an infinite number
Mhm.
of numbers which are between 2 and 1. So it's like not getting like less significant every time, really. Well, it is, but it never has a like stopping point. I guess.
I think I kind of get what you mean.
Because an infinite of 1 is still infinity.
Because the terms are getting smaller, right? Because it's going like first term is 2, but then plus is plus root 2 plus cube root 2 plus 4 root 2. Or I don't know how you would say it, but it would still go to infinity. Is what you're saying?
Oh, yeah, I think it would, because if you're doing, maybe.
Because that kind of makes, like, if I were to reason that out, it makes sense because it's sure the values are decreasing, but it's still like adding on to the sum. So
Yeah, that's what I'm thinking. So I did in fact not pick a conversion.
Yeah.
My bad, gang. I think Matthew, you should pick a conversion one. Gotta think real hard about this one.
sorry.
actually convergent, I just found out.
Oh yeah. To what?
I don't know,
Okay.
but I just ran the
What is conversion?
ratio test.
So it's
Okay, so I just found out that your sum, Matthew, is convergent, right? But y'all still can't figure out the actual sum, which proves my point that very, very, very seldom will you actually be able to figure out a genuine, definite sum. You'll never be able to find it. It's very difficult.
Just by it's difficult to do it by reason.
Yeah.
Okay.
It's difficult to do it by reasoning, it's difficult to do it algebraically, it's difficult to do it critically. It's difficult to find whatever this thing equals, which is something about it that kind of trips you up. Okay? So the closest we can ever get to finding this value is first off to find if it's convergent, which is, this is something you'll learn in 11.6. And then the second thing you need to do is at least estimate it, which you also find out consistently in 11.3 to 11.6. But the point I'm trying to make here is that you'll very rarely be able to figure out what that is, which is why you need to know stuff like this. Okay? Throughout 11.2 to 11.6, you'll find a bunch of stuff like this where, oh, the sum equals this, which is a constant that you can actually solve for, therefore you actually know the sum. You need to know stuff like this so that you can actually figure out the sum. Because if you don't have this, you're probably never going to find the genuine sum, which is just what I've been trying to show. Okay. So, yeah, that's it. That's a little tangent that I was talking about, basically. So that's it.
Just killed my calculator.
Did it error or something?
Wait, so can we apply?
It's gonna take a little bit.
Can we apply that to Matt's sum or like his series?
What do you mean by
A
the
over
geometry?
Like so R would be the constant that's multiplied by. Oh no, you can't really do that.
Yeah, you can't. That's the problem. You need to first figure out if the series is geometric, then figure out if you can use the thing. Right? Alright. So that's geometric stuff. There's one more series. Alright. There's these alright, let me give you an example. Number 8. Alright, you need to show this through reasoning. Show that the series, the sum from n equals 1 to infinity of 1 over, and then all of this I'm about to say is in the denominator, n times parentheses n plus 1, is convergent, and find its sum.
Can you
Tell
write that
me-
down?
What?
Can you write that down?
Yeah.
Okay.
N denominator is n times the quantity n plus 1, right?
1 over?
1 over n times the quantity n plus 1.
Okay.
So we have to prove it's convergent.
Okay. Typically, I just told you guys to do something that's very difficult to do, which is find the sum. But you can do it because I believe in you. And the power of willpower and friendship is the real treasure you may prolong. I'll help you out a little bit here. This is something, this series, I'm actually introducing you to the next series. And it's kind of an informal one, but it works anyway. Just do me a favor and write out the first couple terms, like the first 4 terms. So say this 4 1 over. first thing you can do here is check its telescoping. Now just do what I do. Right. Yeah, this makes sense, right? Is that true?
Oh.
That's right.
Yeah.
And the first one is, sorry, just right out.
Yes, that makes sense. That does make sense.
How?
Because, watch this.
That's fine.
Wait, hold on. No. Yeah, watch this. Make it common denominator, so.
Does anyone see a pattern?
Oh, okay.
Yeah. Mm-hmm.
Pattern.
Sorry. Okay. Does anyone see a pattern here? Can I write it out? See if you can use reason.
It's like all the terms are getting smaller. Well, that's so it's decreasing.
Oh.
Smart.
Oh.
Oh.
So
that's
everything
the
literally cancels except for one, so it ends up being one up here.
Oh shoot.
Wait, that's.
You know.
And then to that
Mm,
end
yeah.
term.
And then whatever before this is probably gonna cancel with this too, right?
Mm-hmm.
So you have this is what you have, which means this equals 1. This one. You're so goated. Now, and just FYI, scratch, note, don't ever write this sum
Mm-hmm.
as n equals infinity. Don't do that. Can't do that.
Mm.
Because n cannot equal infinity ever. N can approach infinity. So instead what you can write is this. This is what you should